Okay, today we're talking about 3.5, finding slopes of lines. This should be just a quick review from algebra. If we talk about the slope of the line, I usually like to think of a guy that's like walking up our line, and if he's walking up the hill, that's a positive slope. And if it looks like he's walking down a hill, you always look at it from left to right. If he looks like he's walking down a hill, it's a negative slope. Okay, and the way you find slope is by looking at the rise over the run. So that's the change in the change in y over the change in x. Okay, and our regular formula is y2 minus y1 over x2 minus x1. A zero slope, that would be like if our dude was walking on our line, and he's not walking up or down, he's just walking straight across. That hill has no slope. Okay, and then an undefined slope would be if we had our guy and he was trying to walk up a vertical line. So it would look like this, and well, this guy is just going to run straight into the wall. He can't really go up, so that's undefined. Okay, so let's go ahead and talk about identifying parallel and perpendicular lines. Okay, the slope of parallel lines, they're going to be equal. Okay, they're going to have equal slopes. And in perpendicular lines, there's two ways you can find it. You can take the slopes of your two lines and multiply them together, and if they equal -1, then you know that they're actually perpendicular. Okay, or you can think of them having opposite reciprocal slopes. Opposite reciprocal slopes. And when I say opposite, that means the opposite sign. And reciprocal means if it's a fraction, you're going to flip it. So an example would be if we had a slope of 10, the opposite reciprocal would be, well, you can write any whole number as over 1, and so if you flip it, you get 1 over 10, and since this one is originally positive, the opposite would be -1/10. So 10 and -1/10 are opposite reciprocal slopes. Alright, let's try some examples. We're going to find the slopes of A, B, C, and D. Okay, now when we're given a graph, we can find this one of two ways. We can either use our slope formula, which is y2 minus y1 over x2 minus x1 to find our slopes. And all you have to do is find 2 points that are on our line. Or you can actually count the spaces. I'm going to do the first one both ways, and then we'll probably just count on the next two. Alright, so I'm going to look at line A first. A is blue. Okay, so we want to count how much it falls. Okay, so since it's falling, that's 2 spaces. It falls 2. So if we're going down, that means it's negative. And we go over 2 spaces. And we see that our slope of A is -1. Okay, so that's just taking 2 points on here, and we're just counting the spaces in between. So it's always rise over run. Okay, now if we want to do it with the 2 points, we can take 6, 4, and 8, 2. Okay, I'm going to label 6, 4 as my x1, y1, and my 8, 2 as x2, y2. And then I'm going to plug them into my formula accordingly. Okay, so y2 is 2, y1 is 4, so 2 minus 4 over, x2 is 8, x1 is 6, so 8 minus 6. On top we get -2, on bottom we get 2, and when we reduce we get -1 as my slope. Okay. Alright, we're going to find the slope of B. Okay, so if we look at B, we know that this is going up. So if we had my little dude and he was walking up the hill, we know we have to have a positive slope, okay? And we can just count on here. So I'm going to take the point 4, 0 and 6, 4, and I'm going to go up 4 over 2. So my rise was 4, my run was 2. 4 divided by 2 is 2. So my slope is 2. And that's for B. Alright, so let's take a look at C. C is going straight across. We have our guy. He's not going up or down. Okay, so there's no slope. Our slope is 0. Okay, he's not going up or down, so it's not positive or negative. And that was for C. And then if we look at D, if I place my guy here, and he can't walk up that line. Remember, when you can't walk up the line, or you're straight up and down, that's an undefined slope. So D is undefined. Now, I do want to show you with the slope formula on that one so you can see it a different way. I'm going to take the point 6, 0 and 6, 4. 6, 0 is going to be my x1, y1. 6, 4 is going to be my x2, y2. And I'm going to plug them into my original formula. Y2 minus y1 over x2 minus x1. Y2 is 4, y1 is 0, x2 is 6, x1 is 6, and you see we get 4 over 0, and we can never divide by 0. That's why it's undefined. Okay, let's try another example. It says find the coordinates of P along the directed line segment AB so that the ratio of AP to AB is 3 to 2. Okay, in order to divide the segment into a ratio of 3 to 2, think of dividing or partitioning the segment into 3 plus 2, or 5 congruent pieces. Okay, so point P is the point that is 3/5 away from point A. Okay, so point P is 3/5 away from A. Okay, so the first thing we need to do is to find the rise and the run from point A to point B. And we're going to leave the slope in terms of rise and run, and we're not going to simplify. Okay, so if we count up, we're going to get 6. And our run, 1, 2, 3. Okay, so we get 6 over 3. Okay, so the next thing we need to do is to find 3/5 of our rise and 3/5 of our run. And the way you do that is just by multiplying. So for my rise, we have 6 times, we have 6 times 3/5, and then for my run, it's 3 times 3/5. And if you actually calculate this, your rise is 3.6 and the run is 1.8. Okay, our last step. We have to take each of these things and add them to my A coordinate. So if we think about the run, okay, the run deals with my X values. Okay, so I'm going to take 1.8 and I'm going to add it to my X coordinate. So 3 plus 1.8. And then if I think about the run deals with my Y values. So I'm going to take the 3.6 and add it to my Y value of A. So we get 2 plus 3.6. So that means where I need to put point P. Sorry, this should be a P, not an A. 3 plus 1.8 is 4.8. 2 plus 3.6 is 5.6. And that's where point P needs to be placed. For our last example, we're going to determine which of the lines are parallel and which are perpendicular. Okay, so the easiest thing to do would be to find the slope of each of these lines. So we need the slope of A. Okay, if we count, we get up 1 over 3. So the slope is 1 over 3 for A. On B, we count up 1 over 2. So the slope is 1/2. For C, we count up 1 over 2. Okay, and then for D, I'm going to start at -3, 2, and go to -2, 0. So I'm going down 2 over 1. So since I'm going down, that means -2 over 1. Okay, then I have to think, okay, parallel lines have the same slope. Okay, so if I look at B and C, they're both 1/2, so these are parallel. Okay, now I also need to find which ones are perpendicular. So I can do this one of two ways. I can remember that they need to be opposite reciprocals, that means different signs, and they need to be flipped of each other. Okay, so I can see that 1/2 and -2 over 1, those are actually opposite reciprocals. Okay, or what you can do is if you can take the two slopes and you can multiply them together. If you get a -1, then they're perpendicular. So 1/2 times -2 over 1. If you multiply straight across, 1 times -2 is -2. 2 times 1 is 2, and this reduces to -1. So our actual answer, the whole answer it's looking for, is that lines B and C are parallel. And lines B and D are perpendicular. The upside down T stands for perpendicular. And the last one is lines C and D are perpendicular. Okay. That's it for the review for 3.5. If you have any questions, don't forget to ask your teacher. And they will also be doing more examples in class.